starts the exact same way. We started with this. We started with that in 6-1, cross, multiply, and solve. It was easy, because you were given what to do, you were told what to do, and you knew how to do fraction equal fraction. You pressed buttons and you were done. 6-2, you had this then. Please stop eating. You were given that, which then led to you filling in the blanks of, which led you to press the button on the calculator and solve. In 6-3, you had this. Which led you to do this. Which led you to do this. Have you noticed the pattern of what we've been doing?
Yeah.
What's the pattern? Just adding a step. Everything that we've done is just one step on top of what you've already done. Yesterday you did this, or the day before when we started talking about the actual, or yesterday we did the similarities. You had to get two triangles to be similar. To be able to do this one, and then this one, and that one. That's all this stuff is, guys. It's one extra thing on top of another. Same thing goes for today. Today, instead of looking at two angles, we're looking at three sides, or two sides and an angle. It is basically going to get you through the exact same scenario as everything else that we've set up. It's just one other way to start the problem. After we start the problem, all the other processes are the same. So none of that changes. And we've had really good luck with this stuff so far in the other two classes. And we've had a good chunk of time to start on the problems, and most people are flying through it. So here's what happens then today. Today what we wind up with is being able to say this. If the three corresponding sides of two triangles are proportional, the triangles are similar. So just like before when we talked about congruencies, you had to have everything congruent, sides and angles. And then after time, we started using the alphabet soup of side, angle, side, 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 and all that stuff. We started having to show less work. Same thing goes with this. When we started talking about proportionalities and similar figures, you had to have all the sides proportional, all the angles similar, or sorry, all the sides proportional and all the angles the same. And we started to peel that away. Nope, all you have to have is two angles the same. Automatically works. Same thing here. If all three sides have the same ratio, you're fine. They're similar figures. And you go on. And then you set up your statement. And then you substitute in. And then you cross multiply and you solve for x. That's all it winds up being here. Okay? The difference is between what we're doing today and what we did back in 6-3, I believe. In 6-3, they gave you the similarity statement. You solve for x. Today you're going to solve for x that makes the similarity statement true. That's it. You do the exact same thing. Fill in the blanks, or write the statement, fill in the blanks, solve for x. Same stuff. Okay? Let me give you an example here. This actually goes by sabotage. You try to kill me. Oh, be over here.
Yeah.
Oh, that's right. You're smart. She does like you. She stuck up for you with the chair. She's happy to use the chair. You're good. I'll teach you. I got nothing. I really don't. So what we can do then is this. You can ask a question of, you'll be given three triangles, and it's going to ask you which ones are similar. And it'll ask you which ones are similar to a specific one. So in this case, they're saying, hey, is either triangle PQR or triangle STU, S-T-U, is that similar to triangle XYZ? Basically what they're asking here is the following statement. Is triangle PQR similar to triangle XYZ? Or is triangle PQR. Oh, not PQR. I forgot about stupid. These guys are stupid. So all you're doing is setting up two statements, fill in the blanks, and see if one of them works. Both of them might work, one of them might work, neither of them might work. It's just wording it ever so slightly different. That's it. The rest of the math is a piece of cake. You write it out. PQ, QR, RP. XY, YZ, ZX. Notice again, all I'm doing is filling the blanks via letters just like we have them. I haven't changed it. See ya. And then it's just a matter of filling in the blanks. That was fun. That was generally well timed.
I didn't find it funny because I actually did that in French. I walked up before.
So let's see, what's PQ? 35? XY? 25? 21? 15? 42? And 30. Stu is... So, when you set these things up, the only thing I have to tell you to be careful with here is really just watch those letters. Watch the letters as you're putting them together. Make sure that when you write out those statements, you're putting them in order. And the order you put them in matches with the other triangle. That's the biggest trick with these things. If you keep it consistent, you're going to be fine. That's just the idea of doing it that way. So as you fill in blanks, you get 35 over 25, 21 over 15, 42 over 30. Those all simplify to the same thing. So do these three supply to the same? Oh, okay. So yes, you are right. But this one, do these guys all simplify? Yeah, these are all 7 over 5. They have a scale factor of 7/5. 7 to 5. Okay. The other one doesn't. And it's really obviously it doesn't because that equals 1, that is more than 1, and that is less than 1. Last time I checked, 1 can't be, one can't be the same thing as more than itself or less than itself. It's kind of weird like that because 1 is just 1.
That's confusing.
Sure.
I was just kidding.
I'm messing with it. I was just doing awkward pause and it didn't work very well. So,
How do you actually read the letters? Like, know which one goes?
it tells you. It'll tell you the letter.
Oh, okay.
Same deal. It tells you the letters.
What happens if they don't give you the letters?
Then what you'll do, you'll try and match up via an angle like we did yesterday. You match up the angles, then you work your letters out of it.
Okay.
So it just depends on what they give you, what information they have. With the stuff when you have just straight sides, you're gonna have to know something about the letters. Like in this next one, this next one is a prime example of when you have to know what letters to start with.
Okay.
Because here they're gonna say find the value of x that makes them similar. Well, what do you want similar? I want ABC to be similar to DEF. So it's telling you specifically what letters have to match up. Great leading question.
Okay, where's this good?
Addition schools, playing golf.
Oh, that's
are you laughing? What's wrong? So, what do you think you're going to do first?
Write down the problem.
Write down the problem. Good chance. You are SMRT.
Thanks, Homer.
Hey, Toby. Do you know who Homer Simpson is? Okay, just wondering. He's no Ebenezer Scrooge. Homer. Elmer Fudd was a different.
Right.
You know who that is? Really?
Then my little brother said, I don't know who that is. She said, I don't understand why he wouldn't know.
Really?
Right. Wait, which one? Except you said
Such that, yeah. Sorry, my abbreviations. I got ahead of myself here. Find the value of x such that triangle ABC is similar to triangle DEF. So, if you guys are so awesomely inclined to go into a great profession known as math in college, or have to take upper level math classes, you wind up doing a lot of things called proofs. I know proofs is really a 6-letter word, but most of us think of it as a 4-letter word. But there's a lot of, yes, you just caught that. A lot of us, when you take those classes, there's a lot of abbreviations, okay? A ton of abbreviations, because math people don't like to spell, nor do they like to use a lot of words. So we abbreviate everything, because the word such that is too many letters.
It's only 8.
I know, but I cut my production down a lot, by a fourth, by saying ST. So I'm using 25% energy, so I have 75% more energy for my brain.
But FT can go into so much more things. Like,
Hey, 2 out of 8 is 1/4, so I did okay there.
he's not science.
Oh, that's what you meant for is ST, science teacher.
Yeah.
Yes, that's what you're going with. What's wrong, Mackie?
ST can mean so many other things.
You're right.
Like science teacher. Stupid tights.
Silly triangle. 6 tarantulas. 7 turtles. Stinky time.
Oh, I know what it is.
Smelly thought. So again, what you wind up doing here is you get a problem that looks like that. All you're doing is you're going to write out your statement. You write out your statement, and then you fill in the blanks with what you know via the diagram. 4, 12. Is there enough information there to solve for x for one of them? Absolutely. Now, the value of x should be the same for both of them, so you just set it up right here. Do you have to use 4 over 12, or could you simplify it and use the scale factor? By all means, but do you have to? No, you don't have to. The only reason why I say that if you can simplify it, just makes the math easier on your brain, especially if you're not using a calculator. Good.
Abbreviations.
Or abbreviations, exactly. So if I set this up and I write it as 1 over 3 is x minus 1 over 18, cross multiply, I get 18 is 3 times the quantity x minus 1. Distribute and solve, you get x is 7. Very good. you get x is going to be equal to 7. Excuse me. Now, if you think about it, we know that we have this scale factor of 1/3. If I substitute in for 7, what's 7 minus 1? 6. What's 6 over 18? 1/3.
So it works.
What's 7 plus 1? What's 8 times 3? And what's 8 over 24? 1/3. So you use that scale factor like we did all the other times to solve for missing parts, same way. Okay? Math doesn't change. Just the way that we started this problem is different. The way it was worded. Such that in a different way. Okay? What's wrong? You look bewildered.
How did you get 7?
Cross multiply. When you cross multiply this, you get 18 times 1 is 3 times the quantity x minus 1. That's 18. That's 3x minus 3. Subtract 1, you get a 21. Divide by 3. Okay? Just got ahead of myself. All right? Hey, same thing goes for when we want to do something different. If two sides same deal goes for if you have what basically works out to look like a side angle side scenario. If two sides between two triangles are proportional and their included angle is congruent, the triangles are similar. So if you've got two sets of corresponding proportional sides, the angle between those two sides, if those two angles are congruent, you wind up with a scenario that mirrors the idea of side angle side, but it's what we call a side angle side similarity. And it works itself out. Same deal. You're dealing with triangles, you're going to be given, hey, find a value of x that makes these two triangles blah, 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 and blah, 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 similar to one another. Well, you'll look at a diagram and decide, do you have to use angle to make it work? Are you going to use the three sides to make it work? Or are you going to use this scenario of two sides and then an included angle to make it work? It's just a matter of writing it out. That's it. Okay? Excuse me. Question? You had the question face for a second. I wasn't sure. You? I don't care about you. I'm just happy you're awake. Actually, I do care because I am happy you're awake. Why am I talking to him?
No, I just didn't know when you were talking.
Oh. Ms. Tope had a question face, I thought, a second ago, so I was asking her. But he's awake, so that's okay. Example. Same deal. Hey, find the value of x that makes it something similar. And you're given a diagram. In the diagram, hey, you've got an angle between the two sides. So, again, you're going to do the same exact steps. You start, similarity statement. They tell you what they want it to be in the end. They want it to be PQR and TUV. They want those two to be similar. So it's just a matter of writing out the statement to figure out which parts are going to match up. Once you figure out what parts match up, then you fill in the blanks. Just like every other one of these problems. Excuse me? You? remember some of the problems we had at the beginning of the year? The angle equal free symbol had an exclamation point. It's he just scowled at me too. You shake his head and get it. So sometimes this book is weird. It's not yelling at you as much as you might think that it's yelling at you. If you want to think in your mind that I'm yelling at you, that's fine because I probably am. But it's just that typesetting. It happens a lot. Okay, you see an exclamation point. Technically, it means 60 factorial, which means 60 times 59 times 58 times 57 times, which is a really, 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 really big number. Okay, we don't need to worry about that. So, fill in the blanks. Do I know what PQ is? No. Do I know what TU is? No, so I don't worry about that part. Do I know what QR is? Yes. 30, 24, 3x and a 4, and 20. I love doing that. You guys should know when you see that. You should already it's like Tuesday, first Tuesday of the month at 10 a.m. You know the sirens are going to go off.
I didn't see it. I don't have my glasses on. Yep.
Ezekiel, help her out. Give her your glasses, man. All right. So, do I have to use 30 over 24, or can I simplify it? Yeah. And again, you don't have to if you don't want to. You guys got calculators. By all means, you can use them. But it's just easier. Sometimes to use the smaller numbers or simplified value. 30 over 24, they're both divisible by 6. You get 5/4. So you cross multiply. 12x and a 16 is 100. And you're back to a very fast two-step equation. With any luck in this one, see, subtract 16 is what, 84? And again, you get 7. And no, not every problem about similarity, the answer isn't always 7. It just so happens the first two examples I chose, it happened. It does not happen in the real world like that. You can't just say, oh, the answer's going to be 7. All right, thank you. You rephrased me correctly. Don't answer everything as 7.
7.
If you say 8675309, it can get a chuckle, but you know.
7.
Jenny.
7.
Okay, Evan. I'm just gonna call you Evan easier. You're gonna have to watch that. That's your homework for over Christmas. You have to watch A Christmas Carol. There's a bunch of different versions of it. There's the Disney World, the Disney one, the Scrooge McDuck. The Drew Carey one, that one, not Drew Carey, Jim Carrey. Drew Carey would be funny too. Jim Carrey did one. Bill Murray did one called Scrooged. The original one is some guy dead. I don't know. That's the original. Oh, it's pretty soft. That's tiny. It's a different movie. To be honest with you, that's really all. Yes, ma'am. Go do these, please.
Well, any of these.
I don't know. Give me a second. I will put these up online here in a second. Bless you.
not what we want.
Well, no, like, it's just last year.
Yeah, it is. I don't have any more. Don't rip mine like that.
No, yeah.
I got the.